move to our first presentation of this series. And I think Nicole and Marika both had your cameras on for a second there. Nicole is the lead for the PTAGIS data system. And sorry, Nicole, I suddenly blanked on your title, data coordinator. So she is the person, if you ever have a question. No, and there are others, but we're really happy to have the heart of the PTAGIS system here with us today. And if you don't know Marika, she is with Idaho Fish and Game. And it's a really nice combination of, you know, expert user and expert provider. So with that, I'm going to stop and turn it over to Nicole.
All right. Thank you, Jen. I am a data coordinator, so I kind of provide an interface between our data contributors and data users and our technical folks who build all of the tools that they can use. We build software to help people collect and submit pit tag data to us. And we have a website and a reporting system to help people get the data out and use it. And John Tenney is also here, and he's our program manager and has been working in this program for a very long time. And I have been here for about 15 years, and I'm going to do a demonstration on how to query some interrogation data out of PTAGIS. This is a live demo, which I might be crazy for trying considering the week we've had, but I think our PSMFC IT department has got us all back online. All of our sites are loading normally. The website should be usable by everybody as normal. So I think we are good to go. So this is going to be a live demo, but I just wanted to leave this slide here for additional resources. We have a series of video tutorials available on the website that will run you through how to use the advanced reporting system. If you are new to PTAGIS and how we handle pit tag data, then the data overview section in the PTAGIS data specification will help you get oriented that way. And there's also a query section in the data specification that has a few other options for getting data. There's so many more pages I could link to in the data spec. There's a lot of information there, but those are a good place to start. We also have a frequently asked questions page, and I am available for technical support on anything having to do with PTAGIS. So let's hop right into this demo. So this is the main screen that you will see once you launch the advanced reporting system. You just need to create a free account on the PTAGIS website if you don't have one already, and you can start using the system. I'm going to focus on the Query Builder 2 section of the reporting system. This is where custom queries can be built. You can save the queries for use later, you can export the data, and you can subscribe to have the queries run on a schedule and send the data to you. When you first go into the Query Builder 2 section, you'll see a series of data sources, and you need to decide what you're trying to query in order to pick the correct data source. I'm going to focus on the top 3 because we're focusing on data from pit tag arrays. And the complete tag history is the data source that some of the tools that will be covered in later webinars will be using. So before we get into these, I just want to show a quick demo of what these different sources provide. The interrogation summary will give you one record for each site at which a tag has been detected. And it will show you the first and last, sorry, my tabs are not accessible. Here we go. It will show you the first and the last antenna the tag was detected at a site and the first and the last time. So here's an example for one steelhead that was released on the Klickitat River in April of 2019. And it was detected on all of these different sites here. And the first antenna, the last antenna, the first time, and the last time. One thing to be aware of if you're using this data source is if we take a look at this example of when it was detected at the Dalles, the first time is in June of 2021, and the last time is in June of 2023. So you don't have information about the in-between times. Just something to keep in mind for that. The interrogation details source will give you a record for detection on each antenna at a site that a fish was detected at. So here we can see all the antennas at the Bonneville, Washington Shore, upper part of the Washington Shore ladder here. Here's the antennas at the Dalles, and you get a detection within with a granularity of 1 second. So that's the difference between the details and the summary. And then the complete tag history will give you everything that we know about a fish in PTAGIS. So we can get the event type will tell you if it's a mark, an observation is a detection at an interrogation site, a recapture, or a recovery. And you can get them all in one grid like this. So let's talk about how you build a report. Let's start with a pretty easy example. Say you have a list of tags that you put in a group of fish, and you want to check on that. You want to get all the records for those fish that have been recorded in PTAGIS. So we're going to run a complete tag history report. And we're going to just use a list of tags that I have. You can, if you have them in a text file, it could just look like this, a list of tags in one column in a text file. And let me go over how you build a query first. So over here on the left, we have an index, and these are the tools that you will use to build your query. The first one is to select the attributes, which would be the fields that will be included in your results set. Down here are all the fields that are available to include, and you can hover over them to get a definition. And over on the right are the fields that will show up in your results set. And you can add and remove. You can add and remove things from the left and the right to get what you want. You can do that with a double click, which what I was just doing, or you can use these arrow buttons here. The metrics are, I'm not going to cover these in depth, but these give you aggregatable metrics. So you can get min and max length or dates or weights. But one thing you need to know is you always want to include the default count metric in any Query Builder report. And then the rest of these things over here are ways to filter down to the records in which you are interested. So you can filter on dates and sites, types of events, species, various attributes such as those. But what we're going to look at is filtering on a list of tag codes. So we're just going to find everything that we know about this list of tags that I have. One thing to remember about this is you can use a text file of up to 15,000 tags, and that number could be lower depending on how many attributes you include in your results set. But to use this, you click on the tag in this box here, and then click the import file link here, and just select your file. Once you see your file here, you still have to click the import button, and then you will see all the tag codes load into this box. And you can also paste a group of tag codes in here if you want. They just need to be separated by a semicolon. Once you have your tags, you'll see this green flag light up. this shows you which filter parameters you have specified for this report. And then we can click the Run Report button down in the bottom lower left. And it is running. Give it a second to run. It's finding all the records. I think I had about 300 tags maybe in that text file. It's taking a little bit longer than it normally does because it's a live demo. Well, what I can use this opportunity to show, if you're running a very big query, you can click Add it to my history list. And then it should run in the background and it will show up in your history. And you can, once it's completed, you can just open it up and see all the results.
Nicole?
Yes.
I believe on the page where you submitted that query, for some reason, there was the form field for not in was selected instead of in under the tag. And so now
That's
it's
what I did.
basically excluding everything.
All right. Thank you for that. Well, the other the other problem with the live demo is operator error. So all right. There we go. Let's try that again. All right, here we go. Let's choose the correct one this time. Tag code, list, or text file. Not tag codes to exclude. This explains it. Okay, so click the tag button, click the import file, choose your file, import your tags, and let's run this again. Or for the first time. All right, that's much better. So here is the results page when you run a query. Just quickly at the top, we have menu items that you can choose from. And also each of these menu items changes the button bar, which have quick links to things in there. The report object shows you the attributes that you've included with the green diamond and the metrics with this orange icon. And then in the grid of results, you can see we have it paginated to 300 records per page. The total number of records is 616. You can access a context menu by right-clicking on any column. You can sort by one column or you can sort by multiple columns. You can move columns around. There's a lot of things you can do in this grid here, but I want to talk mostly about exporting, saving, exporting, and subscribing. So once you realize that you have the records you're interested in and you might want to run this report again, you can go to the Report Home menu and choose Save As, and it will save the report into your My Reports folder. You can create subfolders and multiple subfolders within subfolders if you want to. Give your report a name, save it with all of the default options selected down here and click OK. And then you can run the newly saved report. When you save it with all those default options, you will always have the opportunity to change any of your attributes or filter parameters that you have selected on this page. So everything that you've already selected is there, so you can just click Run Report and it will run it, but you can change it if you want to. To export these records, you would want to go to Report Home, Export, and you can export to a variety of formats. We have Excel with plain text, CSV file format. Plain text are probably the most useful ones. Once you pick a format, you will come to the export options page, and you can change your mind here if you want. The difference between the CSV file format and the plain text, the CSV will always be a comma delimited, and the values are surrounded by double quotes, while the plain text, you can specify a different delimiter and the values will not be surrounded by double quotes. You can choose to export the title of the report and or the filter details. Those will go into the top of the file. And then once you have figured all that out, click the export button over on the right-hand side of the page. You should see it come up in your browser download, and you can save it or open it as such. Once you have saved your report or run your report, you can also subscribe to have it run on a schedule. This is also under Report Home. And you can subscribe and have it sent to you in an email, or you can have the exported file saved onto a PTAGIS server and access it through a URL using the PTAGIS web API. So to do an email subscription, you would select that. You can choose a schedule to run your subscription on. By default, it will come to your primary email, which is the email account, email associated with your PTAGIS account, but you can add other emails to that if you want to. You can type one in and it will be saved for your future use. The delivery format here describes how it will be sent to you. If you choose HTML, it will be sent as a table in the body of your email. If you choose any of these other formats, it will be sent as an attachment. And you can choose to compress the CSV or whatever file format into a zip file here. This will be the file name, and you can specify a different subject and a message to go into the email. Check send a preview now to run this subscription right now and send an email right now versus at 2 a.m. and make sure that it's doing what you want it to do. You'll see this confirmation at the top, and shortly I would receive an email that would look something like this. And here's my zip file. The other way you can subscribe to a report is to a file on the PTAGIS server. So you click the file option. Here you have the same schedule options as well. The location should always be web API. You can choose your delivery format, and then we also want to check send a preview now. Here's the file name to look for, and you can also specify to have a notification email sent to you when it's available. So now where you can find this file on the server, you can find it by going to the dashboard, and under the advanced reporting link section on the main page of the dashboard, there's a MicroStrategy exports link. And this shows all of the files that have been exported that in the manner that I just showed. You can sort these column headers, and here's my file that I just created. So I can click this link right here, get report, and it will download. But I want to show you the construction of this link because it's actually using our API to grab the file, and you can use it for anything. So it starts with api.ptagis.org, then reporting and reports would be the next section. And then this would be specific to you, your username in PTAGIS system, then file, and then the file name. And all of this can be found on our API webpage documentation at api.ptagis.org in the reporting section right here. And you can even try it out here if you have some files saved. You can get a list of all your files and you can retrieve a particular file. So if I just, so you can use this URL in another system to automatically grab this file. And if you have this on a schedule to run every day at 7 a.m., it will run and it will overwrite this file with all the new data. So let's, and here's our Excel file. Okay, let's see. All right, so that was all using a text file of tag codes to run a query. But what if you want to look at all the tags that were detected at a certain site? So let's take a look at how you would do that. We'll go back to the Query Builder 2 report. We're going to build an interrogation detail report. And for this one, I'm going to keep it simple, and I'm just going to filter on this website or this in-stream site on Asotin Creek. And I am going to, I'll just run it like this for now. And we'll just get all of the tags that have ever been detected at this site. And as long as I didn't mess up, this should not take too long. There will be about 15,500 tags. Oh, I know what I did. Well, here we go. So here's all the tags that have been detected at Asotin Creek. There are about 15,000 tags, but I included a bunch of, I included the ops time and the antenna. So we have 700,000 records here. Once I know that this is the group of tags that I'm interested in, I'm going to reprompt this report and go back to my prompt page. And now I'm going to take out all these attributes except for the tag attribute. Because what I want to do ultimately is find all of the complete tag history for all of these tags. So we're going to just get the tags and we're going to save it as in two different ways. First, we're going to save it as a prompted report. And that means we leave all of these default save options alone, and we'll be able to save it. We'll be able to change anything that we want to change in the future to this report. And then we're also going to save it as a static report. And that is unchecking the keep report prompted option here. Static means that the report definition is static. You can no longer change the attributes included or any of the filter options, but the results will update if any new results match those filter options. When you have a static report like this, it will just run and return the results without giving you that prompts page. And this kind of static report can be used as a filter on the complete tag history. So let's go back and do that. Back to the Create Query Builder page. We'll run another complete tag history report. This time I'm going to include some of the attributes that would be useful for some of the other tools that we'll be following up later in this series. Tag and event type are good. Instead of event site, event date, event release site, and event release date, I'm going to change those out for the event site code, which will only have the code and not the site name. The event date time, and the event release site code, and the event release date time. And we can also add the mark species, which is the species that was designated when the fish was first marked. If you choose event species, you will get the species designated for each event. But since there's no species designated for an observation event, it will be blank for all of the observation records, but the mark species will be complete for everything. And you can also include all of the observation details, such as antenna group, antenna. And you can include other mark attributes if you want to in this, but I'm going to keep it right there with these. So let's scroll down to where we can filter on tag code again. And this time we're going to use tag saved report. When you click on that, you will see your username here in the left-hand box. Click on that and then click on My Reports, and you should see your My Reports reports, and then you want to choose your static report and run it. So we're getting the complete tag history for a little over 15,000 tags. This one will take just a little bit longer. One thing about this process is whenever I run this complete tag history report, it will first run that interrogation detail report, and it will get any new records that have been added to PTAGIS that meet those the filter parameters that I set up in that first report. And so here we have our complete tag history for all the tags detected at the Asotan Creek in-stream site, ACM. So this is close to the end of my time. I just wanted to show a really quick where you can find your subscriptions is over here, and you can edit them. You can edit who they go to when they run using the edit button. You can change the filter parameters and the attributes using the personalize, and you can unsubscribe by clicking that unsubscribe link. And I think that's all I got. Is happy to take any questions and let me know.
All right. Thank you, Nicole. A few claps, no doubt. Some comments. I think there was a comment from earlier when we had the slow moment there. You took care of that. Any questions? Let's start with a question there, Russell. Go ahead and turn your camera on, microphone on, Russ.
Can you hear me now?
Yes.
Nicole, thank you for the presentation. I just wanted to preface that some of the upcoming presentations can use that tag history report, and well, I think we'll do stuff to make some of those available. But if you come prepared and take your time to follow the lesson from Nicole today and create some tag files, some of the upcoming tools and products, you can potentially use those files. So thank you, Nicole, very much.
No problem.
Thanks, Russ, for that reminder. I think in my my little distraction at the beginning there, I forgot to even mention that the presenters are, where it's feasible, trying to link these presentations together. And that is why Nicole went first. As we know, a lot of trails lead back to the data system you guys have built, which is pretty awesome. Thanks for that reminder, Russ. Any questions for Nicole? Go ahead, Charles. I'm glad you made it over, Charles. So sorry about the meeting confusion. Go ahead and turn your camera and or audio on.
Mike, there we go. Can you hear me?
There you are. I hear you.
Yeah. Thank you. Hey, thanks, Nicole. Did we record this Nicole's presentation? Is that going to be available?
I believe so, Charles.
Okay, thank you.
Okay, that was an easy question. You got off the hook there, Nicole.
I did. I did.
Russ, is that a new question or is your hand?
It's a new comment or a question, just for general orientation. Again, thank you, Nicole, for the basic information on all the different fields that you can select. Whether or not in the tutorials that you identified, or if there is a few extra minutes at the end, potentially highlighting a few other things like the marker capture sites or the maps, so how you can investigate the data system to find out a little bit more about all the different sites or things that you might want to use, may be helpful, but also not
Sure.
right now unless you're planning. So thank you.
Yeah, I can
Thanks,
do that.
Russ. I see a question in the chat from Tim Taylor. Can you see that, Nicole? You want me to read it?
I can get there.
It says your static file had over 15,000 tags. Then you generated a complete tag history on that file. Was the complete tag history file truncated to the first 15,000 tags, or did it have all of the tags included?
It had all the tags included. Yeah, when you use a report as a filter on another report for tag code, it will use all of the tags in the first report. It's when you're importing a text file of tags that you might run into a barrier with the number of tags that you can import that way.
I see. All right. Thank you, Tim, for your question. Any other questions for Nicole? Keep in mind, Nicole's going to stick around. So if a question pops up along the way, we after the next presentation, we'll have some time, and we have that extra half hour at the end for our office hours. So if that question pops up while Marika Dobos, who's our next speaker, I'm dawdling just a bit. Last call for questions for Nicole. Sort of temporary last call. Don't disappear, Nicole. Thank you so much. It was awesome, and you are so brave. Not only we all know live demos are brave, and we started with the team cast as a warm up, but Pacific States Marine Fisheries Commission has physically moved their offices, which meant moving servers, which meant excitement on their side, and so you know, this data sharing real time is happening. You guys are awesome. All right, Marika, welcome. Thank you so much. I see you now. Marika's going to share her screen. She's going to do some more live stuff. And right, are we ready to go? Okay, I will stop. Thank you.
Thanks, Jen. I wanted to do this workshop because there's a lot of data management tools out there. There's Access and R and Python. So a lot of different options, and all these tools have good purposes depending on kind of the question of how you want to manage your data. I wanted to take a step back and go into, some would say, the prehistoric realm of data management using Excel. Doing this because Excel is a fairly well-known and used tool still, and it has a lot of utility if you know how to use it, and works really great for managing small amounts of data. Obviously, there's other tools out there that can handle larger data sets, but I wanted to focus on Excel. So this will be a live demo too, and just as a backup, I do have exports from PTAGIS, so Amy can put the links to that and also some instructions in case people want to follow along. And I think she'll drop that in the chat, if I'm not mistaken. There you go. So if you want to follow along, these are links to the exports from PTAGIS that we're going to be working on and some instructions. And I'll also have a finalized Excel once we go through this workshop that will be available that has already all the functions in it if you want to play around with some of these functions and tools. So with that, I will start with the live demo and kind of running off where Nicole had already explained. So in this demo, what I'll be doing is working with pit tag array data, specifically at one pit tag array site. However, this can be used for multiple purposes: hydrosystem detections, multiple pit tag array. And what we'll be doing is using tools in Excel to sort through, filter, and manage these data for summary and analysis purposes. So we can do this with either an interrogation detail or an interrogation summary. Quick confirmation, are you guys seeing the PTAGIS webpage? Okay. So I will be working on an interrogation detail. And just to run through this quickly, normally in my attributes, I like to put mark date, mark site, and mark length, because fish are tagged as juveniles and adults. It'd be nice to know the length sometimes. So the observation site example that I'll be using is the Locksaw array, which has two site names, the lower Locksaw array and the upper Locksaw array. So we'll select those. And then in this example, I'll be working with kind of trying to filter out adults from juvenile detections. And I want to do it within one spawn year or one group of fish. So for the observation year, I'm just going to put the last 2 years. So I decided to do steelhead because a spawn year crosses over multiple years. We get some fall detections, you get spring detections. So it's just another layer to try to sort through some of these interrogation data. So quickly, when you run through this, this is just the interrogation detail detections of every fish that were detected on the Locksaw array. I'm going to further filter this down to steelhead and then export it. But these detection arrays has all detections. So once you export that, I'll just start with the spreadsheet. This is what you get. So this is just for steelhead, is the example I'm using, because there's a lot we're going to be going through. So these this export has pit tag codes, rear type, whether they're wild or hatchery, the two site names for the Locksaw array, and where they were released, and then where they were tagged. So the first thing we want to do is we have these big data downloads, and we want to try to sort through some of this. And I'm going to put all of the fields that I'm working on the far left-hand side, so that if you want to add data later on, you can just save your report query from PTAGIS and then just add on to these. And then all of the functions that I'll be working with will just be run-ons for each additional information you add to these tables. So first, what I'd like to do is start with if functions. If functions are great. These are logical functions. So they build on conditions of how you want to sort and state information. So what I'll do here is I'll sort this through from oldest detection to newest detection, so chronological order, and then sort through PIT tag codes. So what this does is it alphabetizes the PIT tag codes and orders their detections on this site. So first detection was on the lower array, second detection was on the upper array for this PIT tag. Now what we want to do is identify the, for example, the first detection. So if we hit equals if statement, it gives you these options to have what condition are you wanting. And right now, I just want the first, I want it to be able to identify the first detection from other detections. So we can do, since this is ordered, we can pick the first PIT tag, and the condition is if this PIT tag equals this, then it's a duplicate. And so I'm going to tell it to enter 0. If it's not a duplicate, it means it's the first detection of that PIT tag. So I can enter 1. And then if you run that through, 1 is going to represent the first detection of each of these PIT tags. You can do these in text code too. If I wanted to identify it as first instead, I would just put first in the text. And then it'll identify it. So it's a very handy tool to use to start sorting through your data. I'm going to leave it as 1. Another thing that you can do is use the if function to order the PIT tags. Since this is a detection and interrogation detail, we can use the same if statement, but a different condition. So if this number does not equal 1, then I want 1 added to the one above. And I'll show you why I did this statement. Oops. Because I missed a parentheses. Okay, and then if it does equal 1, I just want it to be 1. So what this statement then does is it now has ordered all the detections. So for example, you have this PIT tag right here was detected multiple times. With that statement, I was able to order all these detections from first detection to its 8th detection. So these tools allow some utility in trying to manage how many times these fish were detected, what was its first detection, and you can even do this with the last detection if you want first and last detections. Another thing that I wanted to show with the if statement is because steelhead adult data spans 2 years of detections, we want to identify spawn year. So we can add another field, and this is going to be an if statement to identify certain spawn year. And we're going to use this observation date as part of that statement. So I'm going to identify a time frame, so 6/30/2024 to 6/30/2025. And I want to be able to pull everything that would be considered spawn year 2025 adult steelhead from these data sets. And so these are the time frames that I'll be using. So we can use the if statement again. And my logic is if might be faster if I just do, let's see. If this date is greater than or equal to 6/30 and it's also less than this date, is how I'm going to identify a spawn year. So a couple of things that when you're building these is we want both of these statements. So we're going to add and here. So we want both of these logical statements to be used. So I also want to freeze these. I don't want it to run out. So if I want to lock these cells in, you can highlight those and press F4, and that locks those cells in. I'm going to do the same with this. Now there's my logic statement, and then I want to assign names to that. So if that statement holds true, I want it to assign it spawn year 2025, and if not, assign it an NA. And then if we follow that through, it identifies fish, the detections that were in this time period between these two time periods. And I will assign those spawn year 2025. Now, we have juvenile detections and we have adult detections. And so one tool that's kind of helpful is what was the time span between the time a fish was marked and the time a fish was detected at this interrogation site. So we can use a date if function, which allows us to calculate that difference. And all that is if you use the dated if function, we're going to take the time that it was marked. So if you follow all the way through, time that was marked to the time that it was detected on the pit tag array. And then with this function, we can do a couple of different things. We can identify that difference in years. So it rounds that difference to 2 years in difference. So you can see that. You can also do this in months. Or you can do it in days. So depending on how you want to look at these data, this allows you to quickly identify the difference in time between the time a fish was tagged and the time a fish was detected on the pit tag array. Now, do note that some of these fish are also tagged as adults. So we'll go into how to identify adults from juveniles furthermore next. So another function that is pretty handy is the unique function. So I'm going to create a tab here called unique. So we have a list of all pit tags. And what I would like to do is just pull all of the unique pit tags from that list. And to do that, in the first cell, all you need to do is enter unique. Come back into this table and then highlight this entire list, hit enter, and now all of those unique pit tags show up. So that eliminates all your duplicates. You can also do this with a duplicate function. However, I like the utility of unique better. Now, now what I can do with this is now I have all my unique tags, and to help me figure out which ones are adults versus juvenile detections, I'm going to actually run an interrogation query of these unique pit tags in PTAGIS for hydrosystem detections. Now, to make life easy, there's two ways you can do this. Nicole already showed that you can put this in a text file and import that tag file into PTAGIS and run the query off of those tags. Another thing that I thought was pretty slick is as long as you have a comma or a semicolon after these pit tag lists, you can copy and paste them. So another quick tool here. I forgot to show you one. The count A function is another one I wanted to kind of go through. All this does is it allows you to count the number of unique pit tag codes we're in here. We'll use this function later, but I quickly wanted to introduce it here because it can be pretty useful tool. So now that we have a column with pit tags and a column with commas, we can use concatenate. Concatenate function allows you to combine different two cells together. So if I want to put these together, I just select those cells, and then it puts all your pit tag codes with the commas together. And now I can just copy this. I apologize if I'm going really fast. There's a lot to cover, and I do want to get to a couple of important things at the back end of this. Okay, so let's go back to create an interrogation summary for this one. And I'm going to do mark length, mark site, mark date. Here in the pit tag code list, we can just copy the full list of pit tags. You don't have to import all of them. It just separates all your pit tag code lists, which is pretty nifty and saves a lot of time. So with this interrogation summary, I just want hydrosystem detections. I just want to be able to know if these fish were detected somewhere in the main hydrosystem to signify adult detections. So I'm just going to select Bonneville adult fish ladder, McNary adult ladder, and then Lower Granite, because I know that we have adults tagged at Lower Granite, and so they will be detected at Lower Granite, but nowhere else. So now we have our interrogation summary of hydrosystem detections for each of those pit tags in that list. So I'll go back to here. I already added this and created a table. So this is exported. And then I already ran the if statement to order this and identify the first detection as 1. I like identifying these as tables. There's some utility to being able to define these as tables that I'll talk through The way to do that is to highlight the first cell, and then you can insert a table and then define this whole thing as a table. And we'll go into why that can be important later. So here's first detections of your hydro system. Now, one of the things that people find Excel difficult to use sometimes is being able to link data from two different sources. In this example, I'm going to be linking information from two different tabs, but you can also link to different Excel workbooks if you want. But just for the sake of trying to be timely, we're going to dive right into this. Oopsie, that's not what I wanted. I use Control-C a lot. Okay, so there are a few different ways to link data sets in tabs or across workbooks. So I'm going to go through a couple of these. We're going to start with VLOOKUPs. And VLOOKUPs are pretty great. They're quick to do. I'll talk about a little bit of downfalls to that and some other tools that might be a little bit more useful. So VLOOKUPs, unfortunately, they have directionality to it. They're very particular. They want your lookup value. So the value you want to look up, say pit tag code. If you want to look this up, your reference in your other data sheet has to be the first column, and it reads it very directionally from left to right. So it doesn't allow you to look at values in columns that are on the other side of your lookup value. So there is an extra step to this. Then if, say, your pit tag code is somewhere in the middle of the table, or you have all this data and you just want to make it more concise, and there's also multiple detections. So VLOOKUPs is a unique kind of one-to-one lookup. And so you need unique, you need to eliminate your duplicates. So what I did was I just filtered the first detections out and then copied the column of tag list and site names and threw it in a new table with its date. It's just the simplest, fastest way to do it. However, you do have to create that new tab. So once you have that table, you can run your VLOOKUPs. So a VLOOKUP, if you don't, I have all these codes in the handout. Sometimes, I wouldn't say always, but for the simple ones, you can look these functions up and it'll give you kind of a cheat code. Do this. Oh. The cheat code is here, but it also, there it is. So here you can kind of click through what's your lookup value, what's your table array, column indexes, the information you want returned back, and then your range lookup, which is false. I want an exact, find this in as it is in this other table or array. So you can do through this where I want it to look up this value. The table array is in this VLOOKUP function. I want to return the second column of that table, and I want it to be an exact lookup. And that's and that's what happens with live. Okay, let's run this again. So want to look up this and that. Wonder what happened. I apologize. Bear with me for a second.
You are doing great, Marika.
It worked before.
Of course.
And
I mean, now
not.
you have a whole bunch of people watching, so it's totally going to be more challenging.
Right.
I mean,
Marika.
I shouldn't say at least your computer's not trying to reboot.
All right.
Mari, that's just mean, you know. I like Caitlin's comment. What's Excel without things randomly breaking? Yep.
We did have a comment from Corey in the chat that it's worth looking into XLOOKUP. I think it's just as easy as VLOOKUP, but it doesn't care what position
through that, Dondo.
you have your index column in.
Okay, I figured it out. I'm going to go through XLOOKUPs. I'm going through different
Thank
options.
you, Corey.
Wow. On the fly.
I didn't like
love
the
it.
table, so I just put the name, so it's a little finicky. So it wants the whole table name instead of just the field. So hydro is the name of what I name this entire table. So if you didn't have a table, then you would do what I did by looking up the column. But because I defined it as a table, I need to put the name. That's why. Okay, so here, what this did was create a connection, essentially looking this function up in this table and then returning back the associated site name of where it was detected. And you can run this out, and then you can see where there are no hydrosystem detections. Then you can kind of reference, now you have time frame, the difference of mark date to detection date. And these two bits of information help you kind of identify which ones are not true adult fish. So that's VLOOKUPs. The two other methods that I wanted to kind of go over were index and match. And index and match combined, and then the XLOOKUPs, which Corey brought up. So index match, it's a two-step process. I'll show you them separately, and then you can combine those codes by embedding one into the other. So the match part of this code, sure. So if we run match, oops. Sure, I'm not losing my space. Okay, so with match, let's see if I remember how to run this right. I don't usually run match index because there's other functions that are better. So it's similar to a VLOOKUP. We're doing the same thing. So we're trying to index and match this to another table. So with match, the first step is matching this to this field. And if you close that, it returns a 2. And so what this is doing is matching this pit tag code in this table and returning back the row that lookup value is found in. So you'll see rows all the way through, and they're listed. Both of these are row 2. The index part is is taking the return of this row. So in index, if you take this field, so this is your return array, and you want to return what is this match. Did everybody see that?
Looks like it's working.
Yeah, I missed something. Because these should still be NA. Let's look up.
Corey has dropped another gem in the chat. And I don't know how easy that is for you to see, Marika. I'm happy to read it
Yeah.
for you.
I've had issues before where matches will be incorrect if I don't put 0 at the end of the match equation, which I think might be what's going on there, because I see a whole bunch of 5s on your match column for a couple of different pit tags. Like you got 4437 ending in 4437 ending in 8D.
Oh, yeah, you're right. I did miss a 0. Whoops. There you go. You're right. Thank you, Corey. There you go. That fixed it. That's all right. I forgot about that little argument with match. This takes up a lot of time, but you can combine index match together. Essentially, you're taking the match part and then you're embedding it in the index. So for example, if we take this argument, I don't know if it'll let me do it this way or not. You can take just copy this. Yeah, this is just to show that you can take the match part and then embedded within the index part. So it's running the match and the index in one coding. And that allows you to put it all together so you don't have to do all these different steps. So that's match index. I also want to go through what Corey had mentioned, which is X lookups. X lookups are pretty flexible, so they don't have the directionality that VLOOKUPs have. You can run it just off of your interrogation summary, and they can deal with duplicates. So if it is ordered chronologically, what XLOOKUP is going to do is it's just going to look up the first value and ignore the rest. So if you have this sorted from first to last detection, you can run XLOOKUP. And you can run XLOOKUP because this is a table. You can have your XLOOKUP in a field, a column in the middle, and then look up a value behind it. It doesn't have the directionality and the constructs of VLOOKUPs. So with XLOOKUPs, we are going to take this and look up this value. I gotta make sure I'm running this right. And looking it up in this. So this is where tables come in handy. It just reads the column of the tables. And then, so that is my lookup reference. And then I also want my return reference to be out of here. So it's taking that PTAG code, coming through the list, finding the first encounter, and then it's going to return the site name for that. So once I have that, you can enter an argument too. So there's kind of a conditional statement here too. So if it finds that, it'll return the site name back. But if it doesn't find it, you can tell it that there are no detections for that PTAG array in the hydro system. And you can close that out. Must have missed a... Oops. Let's see, check all of my parentheses. Am I missing a parenthesis? 8, 5, 4, interrogation.
Are you just missing X
Hey,
lookup
Corey, go
at the
ahead.
beginning?
Oh yeah,
Sorry
that's
to
right.
jump in.
Corey's my backup. There you go. So
It's a group learning
I really
exercise. This is good.
I really like X lookups because you can define that last argument. If it doesn't show up in the table, you can assign it no detections. It's one step. You don't have to create another table. You don't have to worry about directionality. It's one step. You just add that argument to another column. So X lookups are great. The one thing that X lookups that I haven't found easy is looking up multiple variables. So far we've only wanted to look up based on one argument. We wanted to find a PTAG code. If you want to do 2 variables, I've still found VLOOKUP, a combination of VLOOKUP and a choose argument to be the best option. So I'm going to cheat a little bit here and come back to do a little copy paste here. So in the VLOOKUPs, I'm going back to this lookup table here. So in this argument, I'm looking at 2 variables. I want to look up, for example, PTAG code. Oh, I entered it in the wrong column. We can do this. And then I also wanted to look up date. So what this argument allows it to do is we're embedding a choose function in here. So we have a VLOOKUP, and within that, we are picking a choose 2 variables. So we want to select this variable as 1 and 2, and then we're looking up 2 variables here. So I created this. We can do, I think this is the same table. I just ordered it differently. So I wanted to return the date that it was detected, and then also the antenna that it was detected on. So I know this argument is messed up because I have it in the wrong order. So let's try this again. And it should be close. So we want this observation date. In this table here, we want it to look up A2 and A3, so that's correct. And then the other table, so this is the first lookup value, this is the first column, and then we put the and in the middle. So we want it to select the PTAG code and the date that it was detected. So these are the two variables, and then this is the return variable, which is C. So there's the two lookup variables, and then the return variable is this part right here. We want a direct one-to-one. 2, 3. Well, of course it's not going to work. Oh, hold on a sec. Let's see. That is the coding though. So I want to choose first value, second value, choose. Let's make sure that this is right.
Corey, just unmute.
Yes, Corey.
Is it missing $B $2 before $B $436? I just noticed that the other ones have $A $2 and so forth.
Oh yeah, you're right. Thanks, Corey. Again. No, great. Thank you for, I need somebody to look at these because I don't do this very fast, but I wanted to get through a bunch of this. So, so this has been the best way, like if you want to look up, if you have a kind of this one-to-many relationship where you have one PIT tag code and you want to return something with two lookups. What it's doing is it's giving back the antenna that it was detected on that given day. This has been the best way that I've been able to do that. So this returned the antenna that it was detected on this date. And then if you come over to here, you can see that it's accurate. It's returning the same data that came out of PTAGIS. Okay, so those are functions to help kind of gather the information that you need to help sort through this. Once I have some of this, again, these are redundant, but once you have these, you can easily start filtering out your data. So if you want fish that don't have hydrosystem detections, you only want fish that were detected in that time period. This is a great way to organize your data. So now I've filtered out all adult steelhead that were detected on the lock saw arrays within that time period for spawn year 2025. Now, because as long as you don't resort these data, those filters will stay intact. So these, since they're lookups, they won't change if you order these differently, like changing these from newest to oldest. However, it will change your order functions, your if statements, because they are based on the order of those PIT tags. You can filter these and then filter these out and it'll stay, but the order is still embedded in there. So this function is still applies, but once you reorder it, it'll run this if statement on the order that you set it in. So just be aware of that. But you can add detections if you're doing monthly summaries, you can add that information, just run that same query with updated data, and then append those new information to this table, drag those functions and filters down. And it's a pretty slick way to keep track of these detection data. Now we're running out of time. Jen, how much time we have? How much do you want to go?
We are, can you hear me? We are almost at 11:30. So we're supposed to wrap up at 11:30, and then we have the bonus time for office hours. But I think we'll start to see people slip away. So,
Okay.
You know, with other
Well,
commitments.
let me bring up one thing. I did wanted to kind of cover dynamic arrays real quick. So let me just bring this up. I've already built this. This will be available. I wanted to bring up dynamic arrays because we kind of went through ways of sorting through, kind of managing detection data, identifying your juveniles from your adults. When dynamic arrays, we didn't really talk about it in depth, but this is kind of where we can put all those pieces together and use it for easy ways to summarize detection data. So these are adult detections from the LOXA array. I filtered just all of the adult detections out. It has all of the sorting functions still in there, the XLOOKUP, the hydrosystem detections. And so we can build these, what we call dynamic arrays. And dynamic arrays are great if you starting to want to build easy ways to have live summaries, because these are dynamic. These tables can be updated with new data. We run all the filters, and so you can do kind of live, more so live data upstream, or data streaming to run these summaries. And all I've done here is just create drop downs. So these, you'll see a lot of the functions we've already went through. So these are dynamic functionalities. So all this is doing is, once you create a table, you have a unique function. In this example, I want to build a drop-down menu of sites. In this case, we only have 2 sites, the lower LOXA array and upper LOXA array. So this is taking the unique function and then pulling those unique site names into a list. Now, what's great about dynamic arrays is you can add new sites to this. As long as the table is defined, you can add data to this, and it should work. New array. And it adds a new site to that. And because these are dynamic, it will add that new site to it. These are drop-down boxes. You can see that it updated with that new array, that new site that was added in this table, which is pretty slick. We're going to delete that. It should return back. There's a 0 there because there's a row added to that table, but if you get rid of that row, it should update with just those values. And it does. So the unique function that we already went through to create drop-down values, you can go pick a cell and go into data validation, and I want a drop-down list. My source is just the cell that I created that dynamic array with. And to keep the drop-down dynamic with that dynamic list, you add a £. And so that just adding the £, means this will be dynamic with the dynamics of this. So if this changes, your drop-down box changes. So I did that with this. And then I wanted to get unique counts of pit tags detected at each of these sites, and then those that were detected on both sites. Some of these you will have already seen. I'm not going to, for time's sake, go through all of this, but essentially what I did was I pulled up the unique list of pit tags that are associated with this dropdown. So if I go to upper array, or if I go to lower array, you'll see that this changes, and you'll see these number changes. I can go in through and change these, and it updates all of these numbers, all these pit tags. So these are unique pit tags associated with the select site in these dropdowns. So here we have 119 unique adult steelhead pit tags that were detected on the upper Lochsaw array, 55 detected on the lower Lochsaw array. To find those that were detected on both is just a count if function. Essentially what this argument is doing is it's comparing these two lists. So if the reference to this is the first column here, so the first argument is from this list, which of these that are referenced in this list show up here? If this shows up here, make it a 1. If it doesn't show up in this list, have a 0. And so all these ones are associated with tags that are that exist in both lists. So it was detected on both arrays. And then this is just a simple sum of those, including the pound sign so that it's dynamic, so that if you change these for different sites, it stays with those assigned filters. So anyways, that was a very quick way of getting into it. There's a lot that you can do. It takes some time to kind of be able to build this so that you can use it for these types of functionalities. But once you have these done, again, you can just add additional detections to it and use these filters and use these functions. So it takes a little time to set it up, but once you do, you can see some of the utility that comes out of this. So I will stop there and take questions if anybody has. I know that was a lot. I was trying to get through to this part here, and I know I might have confused people. But this is kind of this is where kind of the fun stuff happens. Like once you have the functions and ways to filter and manage your data, you can build a lot of these dynamically to where you can make changes in the table, and these will adjust to those changes pretty easily.
That's awesome, Marika. I want to point out that Ralph has added some additional information on what the XLOOKUP function can do in the chat. He says that it has search mode, so you can look up the last value or first, and that can get you to where you can have one tab to get both.
Okay. Yeah, I am by no means like an Excel expert. I just use Excel a lot because a lot of folks that I work with like Excel, and it's it's just
it is accessible. So, and I'm reading the comment more to make sure that it is in the record of the recording.
Okay.
Because I don't think that the chats are in the recording, correct, Jen?
I think you're correct, Mari. So yeah, that's a good reminder. Thanks, Ralph.
Yeah, thank you. And yeah, there is a lot that I didn't go through. A lot of these functions have additional arguments that you can use, like sorting. You can sort ascending, descending. So I didn't, there's a lot of other functionalities that you can add on to a lot of these to help you with managing your data.
It was a very excellent introduction.
Well, and it's very useful that it's tied to the pit tag data, right? So these are I think the 97 people that we had joined us today all have an interest in these particular types of data. So it's really, I mean, Excel of course has things beyond, there's always something else. So we appreciate that people are chiming in with their insights and their experiences. And Marika, for your bravery to do this, especially live. I see Russ has a question or comment. Jump in here, Russell.
Yeah, thanks, Marika. I think the main purpose and what we were trying to do, we're hosting this workshop, is to identify these types of tools and these equations and have a community of practice where we can share this information. And so we see the comment from others already about other equations, and we're coming up and we'll be sharing more tools, Dart, One Fish, Two Fish, other R scripts and other things that can be shared in GitHub. So however we can share these with each other to make life easier for people and like create some templates. I think that'd be a question of something in the future as we look forward to continuing kind of a community practice around PTAG analytical tools and products for the region.
Thanks, Russ. I just asking Amy to drop the links again to the documents that Marika shared at the start of this, so if people missed that. And I think you're going to have another report that we'll share with the follow-up email, right, Marika?
Yeah, I was just going to post this final one. It has everything already done, and you can kind of click and see what codes are in there. And then you can kind of follow along with the handout, and it should match up to the final spreadsheet with all the final coding.
Cool. I do have a few remarks about what's coming up next for our next webinar. If there aren't any more questions, are there more questions? Anybody? Okay, Amy just dropped the links. So the two links that Amy shared are documents that are on, or one's a spreadsheet, one's a document rather, on the pnap.org website. Marika prepared those before her presentation. What we'll share after with the follow-up materials is this report that she's created during this exercise, so you can tie those together. Okay, I'm going to share my screen. All right, Marika, I'm going to take it away. We can circle back if people want to linger. We're technically in the office hour section, but I want to mention a couple things about next week. We're very excited to have Ben Staten from Columbia River Intertribal Fishery Commission present more on GitHub for data analysis projects. This is his title for next week. If you've been part of our PNAP and StreamNet's Emerging Technologies Information sessions, you know that Ben gave a great talk at our recent webinar series in January, and we specifically asked him to come back and share more about this, because we heard that wholeheartedly from his first presentation in January. So Amy is going to drop a link to the YouTube recording from Ben's previous talk, and we really encourage you to find some time between now and next Thursday to review his portion of that recording. And heck, you can watch the whole thing if you want. So join us next week. We're very grateful, Ben. I think you're out there today. And then I think I have one more slide that is just a reminder. May 1st, May 1st, May 8th, May 15th, May 22nd. You can see all the talks. Hope you can join us. Same time, 10 o'clock Pacific to 11:30, 11:30 to 12 is either we're still talking or we're having office hours where you can ask any question that you wish. So I'm going to open it back up to questions, either for Nicole at the very start of this, where we heard about the PTAGIS data system, or from Marika, we're hearing about a very sophisticated use of it. I see Corey. I'm going to go to Corey, Russ, because you've had a lot of questions.
Well, I don't know how I put two hands up, but anyway, thank you both. That was an awesome presentation. I didn't know you could use VLOOKUP on two variables. That would have come in handy so many times now. But my question is regarding the PTAGIS API. I know, Nicole, you and I have talked about it a little bit. What are kind of the criteria for getting an API key. I had an idea for an app to work on at work that would be helpful to be able to query complete tag histories from individual tag codes programmatically.
Just ask for one. You can email me and I will set you up with one. We mostly have the API key because we just want to have a way in case somebody gets over ambitious with their API data requests that we can shut it off so it doesn't bring everything down. And we want to know who's using it also. So if anything changes, we can let you know, and also we are hoping to provide more programmatic access to data, but we need to know more about how that would be used. So we'd like to know who's wanting to do that and how they want to do it.
Okay, so if I send you an email kind of explaining what my idea is, there's a chance you could grant me a key?
Yes.
Okay, thank you.
That sounds like a great approach, Nicole, where you guys gather how people are using this by those requests. So hopefully people follow that, where Corey was asking about a specific API. Sounds like Nicole is very open to those requests. So you should send her an email, and we will share Nicole and Marika's email addresses in the follow-up to this meeting, which will come from Amy Poles, probably tomorrow, maybe Monday. All right, Russ, I haven't forgotten you have your hand up.
Yeah.
Please.
Just again, at a higher level, for people to be aware of that this series, when it ends, there will be surveys at the end. The fish monitoring work group is trying to organize this series of workshops around these tools and topics that have a lot of interest in sharing common ideas or figuring out ways to improve processes. Whether it's going to be more analytical tools, we're working on processes right now to update potential methods and documentation and species identification keys and things like that, or as I said, R codes or other products. So please stay tuned, and when these presentations come up, sometimes please check in at the websites and in the invites, because there will be additional information provided, potential files or videos of previous information presented that may be relevant prior to attending or some of the content that's coming in. So
Good reminders, Russ. Anyone else have any questions for Nicole or Marika? Okay. I see people are slipping away. It's lunchtime, perhaps, if you're in the other time zone. So I apologize for the little bit of confusion this morning. Had to do with the team's calendar invite that we needed to update, or rather we thought we could update. It proved to be that some people received the update and some people did not. So whether that was on our side here at USGS or on we'll never know, because what we're going to do for next week is you will see a cancellation of the calendar invite that you already have that came from Megan Detloff, and you will see a new calendar invite from Amy Poles. We'll also send an email clarifying all of that first. So you get the email saying thanks for joining and here's what's coming next week. And then after that, you'll see a new calendar invitation. So don't be startled if you see a cancellation. We're not canceling. This is an awesome start to a 5-week adventure, and I'm very grateful to everyone who helped put this together. And I think with that, we're going to sign off, and we'll see you in a week. Same time, same channel. Thank you all.